Hello. So now we'll start our lecture. I will start presenting my screen. Is my screen is visible to everyone? Yes or no? So we'll start the lecture. So in the last lecture, we have started the Bell-Coleman cycle. So before starting the Bell-Coleman cycle, we have seen what are the limitations of using a reverse Carnot cycle in the practical application. So as that reverse Carnot cycle is consisting of two isentropic and two isothermal processes, whereas isentropic processes require extremely high speed and isothermal processes require extremely slow speed. So sudden changes from extremely high speed to extremely low speed in the same device is impossible. Hence, a reverse Carnot cycle is not practicable. So to have that reverse Carnot cycle practicable, we made small changes in that reverse Carnot cycle. That means we did small modification in that reverse Carnot cycle, and after doing the modification in reverse Carnot cycle, whatever next cycle is generated, that is called as a Bell-Coleman cycle. That Bell-Coleman cycle is also called as a reverse Breton, or that is also called as a reverse Joule cycle. That is also called as a reverse Breton, or also called as a reverse Joule cycle. So we have seen that reverse Breton or reverse Joule cycle is consisting of four devices. First one is the compressor. Second one, first one is the compressor. Second one is nothing but the cooler. Third one is called as the expander, and fourth one is called as a Gaurav Tozapurkar. Have you joined the meeting? Tozapurkar. Hello. Is my voice is clear? Yes or no?
येतोय सर आवाज.
गौरव तुळजापूरकर आलेत ना, जॉईन केलेत ना? Okay. So that reverse Carnot cycle, sorry, Bell-Coleman cycle is consisting of four devices. First one is the compressor, second one is the cooler, third one is the expander, and last one is the refrigerator. So only changes in the reverse Carnot cycle. So whatever two isothermal processes were there in case of reverse Carnot cycle, if we are going to replace those two isothermal processes by isobaric processes, if we are going to replace isothermal processes, two isothermal processes from reverse Carnot cycle by isobaric processes, then whatever next cycle will become, that will called as a Bell-Coleman cycle. So in the last lecture or in the yesterday's lecture, I have explained how that process is occurring in case of Bell-Coleman cycle. That means at the inlet of compressor, there will be the air. That air will be compressed isentropically inside the first compressor, or that air will be compressed isentropically inside the compressor. That compressed air will be supplied to the cooler. Inside the cooler, heat rejection process will take place at a constant pressure. So whatever outlet of cooler will be there, that will be provided to the expander. Inside the expander, isentropic expansion process will take place, and after isentropic expansion, the same air will be supplied to the refrigerator. That refrigerator is also called as the evaporator. So inside the refrigerator or evaporator, heat absorption process will take place at a constant pressure, and after that, whatever air which is coming out of the refrigerator, that will be again fed to the compressor, and that process will continue. So this will be called as a closed Bell-Coleman cycle. If open type Bell-Coleman cycle will be there, then outlet of refrigerator will be given to the atmosphere. That means air which is coming out of the evaporator or refrigerator will be supplied to the atmosphere, and fresh air will be sucked during the suction stroke of the compressor. That will be called as a open cycle or open type Bell-Coleman cycle. So the processes which are involved in the Bell-Coleman cycle are nothing but here process 1 to 2. For 1 minute. Process 1 to 2 will take place inside the compressor, and that process so here process 1 to 2 will take place inside the compressor, and that process will be called as a isentropic compression process. Then whatever process 2 to 3 will be there, that process 2 to 3 will take place inside the cooler. That will be taking place inside the cooler. So here you are observing cooler. Whatever process 2 to 3 will be there, that will be taking place inside the cooler, and that will be the isobaric, that is nothing but constant pressure heat rejection process. Then whatever next process will be there, that is nothing but process 3 to 4, that will be taking place inside the expander. That will be taking place inside the expander, and that process 3 to 4 will be called as a isentropic expansion process, and last one is nothing but isobaric heat addition process. So whatever process 4 to 1 will be taking place, that process 4 to 1 will be taking place inside the refrigerator, or that is also called as a evaporator. So that process will be the isobaric heat addition process. If you see the 4 processes which are involved in the Bell-Coleman cycle, then first process was the same, that is nothing but isentropic compression process. So in case of reverse Carnot cycle, first process was the same, isentropic compression. Second process was the isothermal heat rejection. So here instead of isothermal, here we are having the isobaric heat rejection process. Isobaric heat rejection process. So that will be only change. Then third process was the same, that is nothing but isentropic expansion. Fourth process was isothermal expansion heat addition process was there in case of reverse Carnot, but in case of Bell-Coleman we are converting that isothermal process by isobaric process. So if we are going to make the changes in the isothermal processes, or if we are going to replace isothermal processes by isobaric processes, then reverse Carnot cycle will become as a Bell-Coleman cycle. Now we have to draw the PV and TS diagram. We have to draw the PV and TS diagram for Bell-Coleman cycle. So yesterday I asked you to draw the PV and TS diagram. So most of the students or few students have drawn the corrected PV and TS diagram. So once again we will see how to draw the PV and TS diagram for Bell-Coleman cycle. So while drawing the PV and TS diagram, we require the PV chart and we require the TS chart. So pressure will be taken on the y-axis, volume will be taken on the x-axis, temperature will be taken, in case of TS diagram, temperature will be taken on the y-axis, and entropy will be taken on the x-axis. Now here first process is nothing but isentropic compression process. First process we have to draw, that is nothing but isentropic compression process. Out of that first word is nothing but isentropic. What is the meaning of isentropic? Meaning of isentropic is nothing but entropy remains constant. Isentropic means entropy remains constant. So from first word we are clear that entropy of the system remains constant. So if entropy remains constant, so whatever that process 1 to 2 we have to draw, that process we have to draw on the constant entropy line. That process 1 to 2 we have to draw on a constant entropy line. So now what is the nature of constant entropy line? So here on the TS diagram we are knowing that on the TS diagram entropy is taken on the x-axis. So any vertical line, wait, any vertical line on x-axis, any vertical line on x-axis, any vertical line in TS diagram will indicate the constant entropy line. But what about PV diagram? So we are knowing the constant entropy line nature or nature of constant entropy line on the PV diagram. So curve line pointing or curve line which is having the nature likewise, that will be called as a constant entropy line. So whatever process 1 to 2 we have to draw that processes on this line only. That means which will be parallel to this line only. So from first word we are clear that while drawing the process 1 to 2 on the PV diagram, that process will be the curve which will be parallel to this curve, and on TS diagram that process will be the vertical line which will be parallel to this line. Now whatever another word is there, what is the another word? Second word is nothing but the compression. Second word is nothing but the compression. What is the meaning of compression? What is the meaning of compression? Can anyone tell me what is the meaning of compression? So meaning of compression in terms of pressure, volume and temperature is nothing but whenever compression process will be there, the value of pressure increases. In case of compression, value of pressure increases. What about value of volume? Volume of the system will goes on decreasing. And what about temperature? Temperature of the system will goes on increasing. Temperature of the system will goes on increasing. That means here while drawing this process isentropic compression, we have to keep the entropy as a constant parameter. Pressure of that system should goes on increasing, volume of the system should goes on decreasing, and temperature of the system should goes on increasing. Now here if I want to draw that process on the PV diagram, so here if I am considering this as a point number 1, so from that point number 1 I am having two choices. That means I can draw that process 1 to 2 in the in this direction, or I can draw that process 1 to 2 in this direction. But while selecting which direction I have to go, I have to take the reference of pressure and volume, because this is a PV curve. So here the pressure should goes on increasing, volume should goes on decreasing. So where that pressure is increasing, so towards this direction pressure is increasing, volume is decreasing. That's why here while drawing that isentropic compression process on the PV diagram, so I'm going to draw that process 1 to 2 likewise. Are you getting? Now similarly, if I want to draw the same process on the TS diagram, so I'm knowing the nature. So on the TS diagram, that process should be vertical process, and that will be parallel to this axis. But here if I'm considering somewhere here as a point number 1, so I will have two choices. Either I can draw that process in the vertically upward direction or vertically downward direction. So here deciding factor is nothing but temperature. So as temperature is increasing, that's why that process 1 to 2 should be vertically upward direction. So here I will draw that process 1 to 2. So that process 1 to 2 will be likewise. Are you getting? So this is nothing but the isentropic compression process on the PV and TS diagram. Now second process is nothing but isobaric heat rejection process. So here what is the meaning of isobaric? Will tell me what is the meaning of isobaric? What is the meaning of isobaric?
Constant pressure.
So meaning of isobaric is nothing but pressure remains constant. So if pressure is remaining constant, so from point number 2 here, so here from point number 2 I have to draw the constant pressure line. But while drawing the constant pressure line, as constant pressure line is there, that's why horizontal line on this axis. will indicate the constant pressure line. But while drawing that constant pressure line, I am having two choices. I can draw that process towards this direction, or I can draw this process towards this direction. In both the direction, I am able to draw that constant pressure line on the PV diagram. But how can I decide whether I have to go towards left side or towards the right side? So for that purpose, I am having the another word. What is the meaning of another word? That is nothing but heat rejection. Isobaric heat rejection. So whenever there will be the heat rejection process, whenever there will be the heat rejection process, whether volume of that gas or volume of that air will goes on increasing or decreasing. एखाद्या गॅस मधला किंवा एखाद्या एअर मधला जर व्हॉल्यूम त्या एअर मधली जर हीट रिजेक्ट होत असेल तर त्या ठिकाणी त्या प्रोसेसचं किंवा त्या एअरचा व्हॉल्यूम इन्क्रीज होणार आहे की डिक्रीज होणार? डिक्रीज. Volume will decrease because of heat rejection. So whatever gas molecules will be there, that gas molecule will lose its energy, and because of losing the energy, so vibration of that gas molecule will lower down, and because of the same, here the volume of that system will goes on decreasing. So as volume is decreasing, that means I have to draw the process 2 to 3. I have to draw the process 2 to 3 towards this direction, not towards this direction. Here I am not going to draw that process towards this direction, as volume is decreasing because of heat rejection. So I have to draw that process towards this direction. So this is about PV diagram. But what about TS diagram? So here this is the point number 2. So from point number 2, I have to follow the constant pressure line because pressure is remaining constant. So as pressure is remaining constant, so I have to follow the constant pressure line from point number 2. So what is the nature of constant pressure line on the TS diagram? So we are knowing the nature of constant pressure line. So likewise, curved line will be there, which will indicate the constant pressure line. But from point number 2, I am having two choices. That means I can draw the process either towards this direction, or I can draw the constant pressure line either towards this direction. I am having both the choices, either towards this direction or either towards this direction. But which is the correct one? So for that purpose, another word is nothing but heat rejection. So whenever heat rejection process will take place, whenever heat rejection process will take place at a constant pressure, what about temperature? Temperature of that air will goes on increasing or temperature of that air will goes on decreasing? काय होईल टेम्परेचरच्या बाबतीत? ज्यावेळेस हीट रिजेक्शन होत असेल एखाद्या गॅस मधून किंवा एखाद्या एअर मधून, हीट रिजेक्शन झाल्यानंतर व्हॉल्यूम कमी होणार आहे. व्हॉट अबाउट टेम्परेचर? डिक्रीजेस. Temperature will also goes on decreasing. So here temperature will also goes on decreasing. So towards which direction temperature is decreasing? From point number 2, if I am considering this as the initial point, so towards this direction or towards this direction where that pressure temperature is decreasing? So towards this direction temperature is decreasing. So I am not going to draw that line towards this direction. So I have to follow the line towards this direction. Are you getting? So in case of entropy also, whenever heat will reject it or whenever heat will goes on rejecting, the value of entropy will also goes on decreasing. So here towards this direction, as temperature as well as entropy is decreasing, that's why I'm going to draw the process towards this direction. Are you getting? Yes or no? So here in the PV diagram, I will draw the process 2 to 3 towards the left side, and in TS diagram I'm going to draw the process 2 to 3 likewise. So this will be called as a isobaric heat rejection process. Isobaric heat rejection process. Now next process is nothing but isentropic expansion process. Now here also the first word is isentropic. What is the meaning of isentropic? What is the meaning of isentropic? Can anyone tell me? Isentropic means entropy remains constant. Isentropic means entropy remains constant. So here from point number 3, as point number 3 is initial point, so from point number 3 I have to follow the constant entropy line on the PV diagram and on the TS diagram. So on the PV diagram the constant entropy line is likewise. But here I am having two choices. That means I can draw the process towards this direction, or I can draw the constant entropy line towards this direction. And from point number 3 on the TS diagram, as entropy remains constant, so I can draw the vertical line, because here vertical line will indicate the constant entropy. Vertical line pointing towards the downward direction or vertical line pointing towards the upward direction. I'm having both choices, but I have to decide whether I have to go towards this direction or whether I have to go towards this direction from point number 3. So the deciding factor is nothing but another word. What is the another word? Another word is nothing but expansion. What is the meaning of expansion? So here, first of all, we'll clear related to the PV diagram. So what is the meaning of expansion in terms of pressure and volume? In terms of pressure and volume. So in case of expansion, pressure will goes on increasing or decreasing?
Decreasing.
एक्सपान्शन होत असेल तर प्रेशर काय होणार आहे? डिक्रीज होणार आहे आणि व्हॉल्यूम काय होत असतो? इन्क्रीज होत असतो. तर आता ह्या पॉइंट नंबर 3 पासून जर मला लाईन ड्रॉ करायची असेल ज्याचं की प्रेशर डिक्रीज होते आणि व्हॉल्यूम इन्क्रीज होतोय, तर ती प्रोसेस कोणत्या डायरेक्शनला असली पाहिजे? ह्या डायरेक्शनला असली पाहिजे. आर यू गेटिंग? Yes or no? So here in the PV diagram, I am going to follow the line pointing towards the downward direction. And here on the TS diagram, as I am having two choices, either in the upward, vertically upward direction or vertical downward direction. So both vertical upward, vertical downward, vertical line will indicate that constant entropy. So as another word is in expansion, in terms of expansion or in case of expansion, temperature of that gas will goes on increasing or decreasing. If expansion होईल त्यावेळेस टेम्परेचर काय होणार आहे? काय होत असतं? इन्क्रीज की डिक्रीज?
Decrease.
So temperature will goes on decreasing. So from point number 3, as point number 3 is the initial point. So from point number 3, where that temperature value is decreasing, in the vertical downward direction, temperature value is decreasing. That's why I have to follow the process in the vertical downward direction, not to the vertical upward direction. Are you getting? So here I am going to draw the PV diagram. So PV diagram, I am going to follow the, or I am going to draw the constant entropy line, which will be parallel to this line, pointing in the vertically downward direction. And in TS diagram, I am going to draw the vertical line pointing in the vertically downward direction. By vertical downward direction, I have explained all the things. Are you getting? So this is nothing but 3 to 4 process. Now 4 to 1 process. 4 to 1 process is nothing but isobaric heat addition process. 4 to 1 process is nothing but isobaric heat addition process. So for this process, point number 4 will be the initial point, point number 1 will be the final point. So meaning of isobaric, what is the meaning of isobaric? Pressure remains constant. Meaning of isobaric is nothing but pressure remains constant. So from point number 4, I have to draw the constant pressure line. So constant pressure line on the PV diagram is nothing but horizontal line. So I am having two choices. I can draw the constant pressure line towards this direction, or I can draw the constant pressure line towards this direction. Similarly, on the TS diagram, here I am knowing the nature of constant pressure line. So I can draw the constant pressure line from point number 4. That nature of constant pressure line is likewise towards this direction, or I can draw the constant pressure line towards this direction. Now deciding factor is nothing but another word. What is the another word? Another word is nothing but heat addition. What is the meaning of heat addition? In terms of pressure, volume, temperature and entropy. So as pressure remains constant, so whenever you are adding the heat, inside the gas or inside the air at constant pressure, the volume of that air will goes on increasing because of heat addition. Because of heat addition, volume will goes on increasing. What about temperature? Plus heat addition करता है temperature क्या होना है? Temperature will also goes on increasing. And what about entropy? Entropy will also goes on increasing. Entropy will also goes on increasing. Now here on the PV diagram, we have to take the concern of pressure and volume. So pressure remains constant, volume increases. So where that value of volume is increasing, towards this direction or towards this direction? So here, as we are knowing that value of volume is increasing towards this direction. Sorry. So as value of volume is increasing towards this direction, so I will draw the line towards this direction, not towards this direction. So here constant or isobaric heat addition process on the PV diagram will be pointing towards this direction. Similarly on the TS diagram, so I have to take the concern of temperature and entropy. So in case of TS diagram, temperature should goes on increasing, entropy should goes on increasing. That should be at a constant pressure. That should be at a constant pressure. So here the value of temperature is increasing and value of entropy is increasing. Whether value of temperature and entropy is increasing towards this direction? No, because value of temperature as well as entropy is decreasing towards this direction. But towards this direction, temperature as well as entropy is increasing. That's why I'm going to draw the line towards this direction, not towards this direction. So that process will be likewise. So this will be the PV and TS diagram. This will be the PV and TS diagram for Bell-Coleman cycle, that will be called as a reverse Breton or Joule cycle. Are you getting? Yes or no? काय अडचण आहे कोणाला आता यामध्ये? हॅलो, कोणते सांगा काहीतरी अडचण आहे का काय? Have you understood, everyone? Have you understood how to draw the PV and TS diagram? Because here afterwards I'm not going to do this animation for PV and TS diagram for each and every process, because it is consuming near about 1 hour of mine. So for your understanding purpose only I'm doing that. So here afterwards I will directly paste the complete PV diagram and complete TS diagram. Will it be okay? Have you understood the basic how to draw the PV and TS diagram? Yes or no? कोणतरी अनम्यूट करून सांगा.
Yes, sir.
Okay. So here we have drawn the PV and TS diagram for Bell-Coleman cycle. Now for what purpose we have drawn the PV and TS diagram for Bell-Coleman cycle? कशासाठी ड्रॉ केले? आपल्याला काय काम नव्हतं आतापर्यंत. For what purpose we have drawn the PV and TS diagram of Bell-Coleman cycle? Hello? कशासाठी ड्रॉ करतो आपण? अरे सांगा बघू.
Work done. To find work done.
To analyze the system. To analyze, in simple words, we can say that to analyze the system, we have drawn the PV and TS diagram. Analyze the system means if I want to draw the, if I want to calculate the value of amount of heat absorbed during the process 4 to 1, or if I want to calculate amount of heat rejected during the process 2 to 3, or if I want to calculate the overall COP of the system, then to analyze that I have drawn the PV and TS diagram. So here if I want to calculate COP of the system, if I want to calculate COP of this Bell-Coleman cycle, then how can I calculate the COP of the system? कसा कॅल्क्युलेट करणार आहे COP मी? So what is the formula for calculation of COP of the system? Can anyone tell me what is the formula for calculation of COP of the system? How can I calculate the value of COP? So value of COP can be calculated by using the formula amount of heat absorbed divided by work done on the system. Amount of heat absorbed divided by work done on the system. So where exactly heat absorption process is taking place? The system मध्ये heat absorption process कुठे होते?
Inside the refrigerator.
Inside the कोणत्या प्रोसेस मध्ये होते?
4 to 1 मध्ये.
4 to 1 मध्ये काय होते? heat absorption होते. So here I have to calculate the value of QA by using the process 4 to 1. या ठिकाणी जर मला QA ची व्हॅल्यू कॅल्क्युलेट करायची असेल तर मला कोणती प्रोसेस यूज करावं लागणार आहे? प्रोसेस 4 to 1 यूज करावं लागणार आहे. अँड वर्क डन, हिअर वर्क डन, value of work done is nothing but how we are calculating the value of work done. How we are calculating the value of work done? We are calculating the value of work done by using the formula amount of heat rejected minus amount of heat absorbed. हा फॉर्म्युला यूज करतोय आपण, heat rejected divided by heat absorption. Yes or no? होय की नाही? So here, as heat absorption process is taking place during the process 4 to 1, during the process 4 to 1. So now during which process heat rejection process is taking place? During which process heat rejection process is taking place? कोणत्या प्रोसेस मध्ये हीट रिजेक्शन होते? So during process 2 to 3. अरे काय कळतंय का नाही सगळ्यांना? So during process 2 to 3 heat rejection is taking place. So here, as heat rejection is taking place during the process 2 to 3. Now here, as I am knowing that heat absorption is taking place during the process 4 to 1, that is nothing but this process. During this process, heat absorption is taking place, and during this process, heat rejection is taking place. Now, area under PV diagram. By using PV diagram, we are able to calculate the. By using PV diagram, we are able to calculate the. काय कॅल्क्युलेट करू शकतो आपण PV डायग्रामच्या सहाय्याने? Hello.
Work done.
So by using the PV diagram, we are able to calculate the work done or work obtained from the system. And by using the TL diagram, TL diagram च्या साइन काय कॅल्क्युलेट करू शकतो आपण?
Heat absorb, heat reject.
हीट ऍब्झॉर्प्शन आणि हीट रिजेक्शन. आता आपल्याला ह्या ठिकाणी काय कॅल्क्युलेट करायचं आहे? हीट ऍब्झॉर्प्शन कॅल्क्युलेट करायचं आहे. पहिलं म्हणजे ज्यावेळेस मला QA ची व्हॅल्यू मिळेल आणि ज्यावेळेस मला QR ची व्हॅल्यू मिळेल, QA आणि QR ची व्हॅल्यू जर मला मिळाली तर मी काय कॅल्क्युलेट करू शकतो? COP कॅल्क्युलेट करू शकतोय का? तर QA ची व्हॅल्यू कॅल्क्युलेट करण्यासाठी मला काय घ्यावं लागणार आहे? काय रेफर करावं लागणार आहे? TS डायग्राम रेफर करावं लागणार, कारण की एरिया अंडर TS डायग्राम न मला काय मिळतंय? हीट ऍब्झॉर्प्शन मिळते आणि एरिया अंडर TS डायग्राम न हीट रिजेक्शन पण मिळते. म्हणजे जर मला QA कॅल्क्युलेट करायचं असेल, इफ आय वॉन्ट टू कॅल्क्युलेट द व्हॅल्यू ऑफ QA, so how can I calculate the value of QA? If I want to calculate value of QA, so how should I calculate the value of QA? QA कुठे होते? हीट ऍब्झॉर्प्शन कुठे होते? प्रोसेस 4 to 1 मध्ये हीट ऍब्झॉर्प्शन होते. त्या प्रोसेस मध्ये काय होते? हीट ऍब्झॉर्प्शन होते. आता ह्या ठिकाणी एरिया अंडर TS डायग्राम म्हणजे हीट ऍब्झॉर्प्शन कॅल्क्युलेट करायच्या दोन मेथड आहेत. वी कॅन कॅल्क्युलेट द व्हॅल्यू ऑफ QA बाय युजिंग द फॉर्म्युला TDS, बाय युजिंग द फॉर्म्युला TDS किंवा MCP डेल्टा टी. MCP डेल्टा टी. आता दोन्हीपैकी कोणता फॉर्म्युला कधी वापरायचा? हा फॉर्म्युला आपण कधी वापरणार आहे? जर ती प्रोसेस म्हणजे 4 to 1 प्रोसेस जर कॉन्स्टंट टेम्परेचर प्रोसेस असेल, कॉन्स्टंट टेम्परेचर प्रोसेस असेल तर मी हा फॉर्म्युला वापरणार. 4 to 1 कॉन्स्टंट टेम्परेचर प्रोसेस आहे का? आहे का 4 to 1 कॉन्स्टंट टेम्परेचर प्रोसेस?
No.
कोणती प्रोसेस आहे ती? 4 to 1 इज अ कॉन्स्टंट प्रेशर प्रोसेस. जर कॉन्स्टंट प्रेशर प्रोसेस असेल तर मी कोणता फॉर्म्युला वापरणार आहे? हा फॉर्म्युला वापरणार आहे, MCP डेल्टा टी. कारण की ह्या ठिकाणी CP काय इंडिकेट करतोय? स्पेसिफिक हीट ऍट कॉन्स्टंट प्रेशर. स्पेसिफिक हीट ऍट कॉन्स्टंट प्रेशर म्हणजे हीट ऍब्झॉर्प्शन किंवा हीट रिजेक्शन काढायचे दोन फॉर्म्युले. पहिला म्हणजे TDS, दुसरा म्हणजे MCP डेल्टा टी. त्यापैकी TDS कधी वापरणार आहे? जर ती प्रोसेस कॉन्स्टंट टेम्परेचर प्रोसेस असेल तर मी हा TDS चा फॉर्म्युला वापरणार. नाहीतर जर ती प्रोसेस कॉन्स्टंट प्रेशर असेल तर मी हा फॉर्म्युला वापरणार, MCP डेल्टा टी. या ठिकाणी प्रोसेस 4 to 1 आणि प्रोसेस 2 to 3 ज्यामध्ये हीट ऍब्झॉर्प्शन आणि हीट रिजेक्शन होते, दोन्ही प्रोसेसेस कसे आहेत? कॉन्स्टंट प्रेशर प्रोसेस आहेत. दोन्ही पण कसे कॉन्स्टंट प्रेशर प्रोसेस आहे, म्हणून मी कोणता फॉर्म्युला वापरणार आहे, एमसीपी डेल्टा टी चा फॉर्म्युला वापरणार आहे. जर मी आता ह्या ठिकाणी हीट ऍब्झॉर्प्शन पर केजी ऑफ द एअर कॅल्क्युलेट केलं, हीट ऍब्झॉर्प्शन पर केजी ऑफ एअर म्हणजे याचा अर्थ काय झाला, एम ची व्हॅल्यू किती झाली, 1 झाली. तर कसा कॅल्क्युलेट करणार आहे मी, सीपी इंटू डेल्टा टी. So I will calculate the value of QA by using the formula CP into delta T. Now what is the meaning of delta T? Delta T चा अर्थ काय होतोय,
Change in
change in
temperature.
temperature. So there higher temperature is there, T1 is having higher value of temperature, T4 is having lower value of temperature. T1 चा temperature इथं आहे, T4 चा इथं आहे. So CP into T1 minus T4. T1 minus T4, CP into T1 minus T4. त्यामुळे तुम्हाला काय मिळालं, अमाउंट ऑफ हीट ऍब्झॉर्ब ड्युरिंग द प्रोसेस 4 to 1 per kg of the air. ड्युरिंग द प्रोसेस 4 to 1 per kg of the air. आता दुसरं काय कॅल्क्युलेट करायचं आहे मला, QR कॅल्क्युलेट करायचं आहे, बरोबर. QR म्हणजे काय, QR म्हणजे काय, हीट रिजेक्टेड. कोणत्या प्रोसेस मध्ये हीट रिजेक्शन होते, प्रोसेस 2 to 3 मध्ये काय होते, हीट रिजेक्शन होते. सो इफ आय वांट टू कॅल्क्युलेट QR, अमाउंट ऑफ हीट रिजेक्टेड ड्यूरिंग द प्रोसेस 2 to 3, which formula I am going to use, same formula, mcp delta t. So if I want to calculate heat rejected per kg of the air, per kg means if I am going to take the value of m as a 1, so here I will get that value as a CP into delta T. आता ह्या ठिकाणी डेल्टा टी कोणता घ्यायचा आहे, हायर टेम्परेचर मायनस लोअर टेम्परेचर. कोणतं टेम्परेचर हायर आहे, T2 चं टेम्परेचर हायर आहे, T3 चं टेम्परेचर काय लोअर आहे. सो T2 मायनस T3, T2 मायनस T3, T2 मायनस T3. आता QA ची व्हॅल्यू कॅल्क्युलेट केली, QR ची व्हॅल्यू कॅल्क्युलेट केली. जर QA आणि QR ची व्हॅल्यू ह्या इक्वेशन मध्ये पुटअप केली तर मला काय मिळेल, COP मिळेल का, होय की नाही, येस और नो. हॅलो, दाबून 2 मिनिट लक्ष द्या. जर तुम्ही रिस्पॉन्स देणार नसाल, वन डायरेक्शनलाच पाहिजे असेल तर मी डायरेक्टली पीपीटी सगळं तयार केलेलं आहे. फक्त मी पीपीटी वाचून दाखवू द्या का. So here, as I have calculated the value of QA, as I have calculated the value of QR, so I am able to put those value of QA and QR in the formula of COP, and I am able to get the value of COP of the Bell-Coleman cycle. So whatever previous diagram, PV and TS diagram I have drawn, so same diagram I have taken from my notes. So this is the PV and TS diagram of Bell-Coleman cycle. Now I have to draw I have to calculate the value of COP. So for calculation of COP, first of all I will calculate the value of heat rejected by the air per kg, heat rejected by the air during constant pressure process per kg of the air. That means during process 2 to 3, how much amount of heat is being rejected. So that amount of heat rejected during the process 2 to 3 will be calculated by using the formula CP into delta T. Here CP into delta T. Delta T is nothing but T2 minus T3. Similarly, if I want to calculate amount of heat absorbed, during the process 4 to 1 per kg of air, then that will be calculated by using the formula CP into delta T. Delta T is nothing but T1 minus T4. So as I calculated the amount of heat rejected, this is nothing but amount of heat rejected. This is nothing but amount of heat rejected. This is nothing but amount of heat absorbed. So as I am knowing amount of heat rejected and amount of heat absorbed, so I am able to calculate work done during the cycle per kg of air. That is nothing but heat rejected minus heat absorbed. So put the value of heat rejected. Value of heat rejected is nothing but Cp T2 minus T3, and heat absorption is nothing but Cp T1 minus T4. So here, if I want to calculate the coefficient of performance, I am knowing the formula for coefficient of performance. So coefficient of performance is calculated by using the formula amount of heat absorbed, that is nothing but QA divided by work done, whereas work done, value of work done we have calculated here. This is the value of work done. So this is the work done. So put the value of QA from this equation, put the value of QA from this equation, value of work done from this equation. In this equation, I will get the value of COP. So calculate the value of COP. Here I will get the value of COP as a Cp. I am putting the value of QA. This is the value of QA. So this is the value of QA. This is the value of QR, and this is the value of QA. So by putting the value of QA, QR, and QA, I am getting the value of COP. Now here in this equation, as Cp term is constant, if you see value of Cp or Cp term is constant everywhere, here also Cp, here also Cp. So that Cp term will get cancelled, and after cancellation of Cp term, I will get the equation of COP, that is nothing but T1 minus T4 divided by T2 minus T3 divided by, T1 minus T4 divided by T2 minus T3 minus T1 minus T4. Now in this equation, if I want to do the modification, so here if I am going to take the T4 term as a common term, or if I am going to take the T4 term out of the bracket, so here I will get that T4 into, here I have to take the T4 term out of the bracket, here I have to take the T3 term out of the bracket, and here again T4 term out of the bracket. So after taking the T4 term from the numerator out of the bracket, I will get that inside the bracket T1 divided by T4 minus 1 divided by, from the denominator, from the first term, if I am going to take the T3 term out of the bracket, so here I will get that T3 inside the bracket T2 divided by T3 minus 1 minus, here again T4 inside the bracket T1 divided by T4 minus 1. So here if I am going to consider this as the equation number 1, Now here if you see inside the bracket, I am getting the term as a T1 divided by T4, T2 divided by T3. T1 divided by T4 and T2 divided by T3. So if you see the PV and TS diagram, if I see the PV and TS diagram of Bell-Coleman cycle, so in case of Bell-Coleman cycle, process 1 to 2 is nothing but likewise 1 to 2, then 2 to 3 is nothing but likewise, then 3 to 4 is likewise, and 4 to 1 is likewise, and here 1 to 2 vertical line, 2 to 3, this will be 2 to 3, then 3 to 4, this will be 3 to 4, and this will be 4 to 1. I am not able to draw that arrow also because here I am using the pointer. So here process 1 to 2 in the PV and TS diagram, if you see that PV and TS diagram clearly, you will observe that process 1 to 2 is nothing but isentropic process, and process 3 to 4 is again isentropic process. That means process 2 to 3 is nothing but isentropic compression process, and process 3 to 4 is nothing but isentropic expansion process. So for isentropic processes, we are knowing the conversion of pressure into volume and pressure into temperature. So here, as process 1 to 2 is isentropic compression process, so for isentropic compression process, I can convert the temperature into pressure, I can convert the temperature into volume. So we are knowing the, in general, T2 divided by T1. So here as this is the isentropic compression process. 2 to 3 is the isentropic compression process. So for this process, as this is an isentropic process, I can write as a T2 divided by T1 is equal to P2 divided by P1 raised to gamma minus 1 upon gamma, which will be equal to same I can write as a in terms of volume P1 divided by P2 divided by P2 raised to gamma minus 1. तुम्ही थर्मोडायनामिक्स मध्ये शिकला असाल जर प्रोसेस जर आयसेंट्रॉपिक किंवा पॉलिट्रॉपिक असेल तर त्याचं आपण टेम्परेचरचं प्रेशरमध्ये टेम्परेचरचं व्हॉल्यूममध्ये कन्वर्जन करू शकतो आणि त्याचं रेशो काय T2 divided by T1 is equal to P2 divided by P1 raised to gamma minus 1 upon gamma, which is equal to P1 divided by P2 raised to gamma minus 1. So we can write as a T2 divided by T1 is equal to P2 divided by P1 raised to gamma minus 1 upon gamma. If I'm going to consider this as the equation number 2, similarly, as process 3 to 4, as process, here is the arrow. So similarly, as process 3 to 4, this is again isentropic process. So for process 3 to 4, I can write as a T3 divided by T4. I can write as a T3 divided by T4. T3 divided by T4 is equal to T3 divided by T4 raised to gamma minus 1 upon gamma. This can be also equal to P4 divided by P3. P4 divided by P3 raised to gamma minus 1. Raised to gamma minus 1. But as I am not required that in terms of volume, that's why I have only considered in terms of temperature only. So here T3 divided by T4 is equal to P3 divided by P4 raised to gamma minus 1 upon gamma. So this will be considered as a equation number 3. Now, wait for 1 minute. I will change the color of pen. So here, after getting the equation number 2 and equation number 3, after getting the equation number 2, after getting the equation number 2, that is nothing but this equation, and equation number 3, that is nothing but this equation. So here I have converted temperature into pressure. That means in equation number 2 I am getting that T2 divided by T1 is equal to P2 divided by P1 raised to gamma minus 1 upon gamma. And in equation number 3, I am getting that T3 divided by T4 is equal to P3 divided by P4 raised to gamma minus 1 upon gamma. Now, if I check the PV diagram, so in the PV diagram, I am knowing that process 2 to 3 and process 4 to 1. In PV diagram, process 2 to 3 and process 4 to 1, both the processes are कशात process दोन्ही पण 2 to 3 आणि 4 to 1 कशा process आहे कसे आयसोबारिक आहेत म्हणजे कसे आहेत कॉन्स्टंट प्रेशर प्रोसेस आहेत कॉन्स्टंट प्रेशर प्रोसेसचा अर्थ काय P2 is equal to P3 as process 2 to 3 and process 4 to 1 are constant pressure processes. That means here value of P2 is equal to value of P3 and value of P4 is equal to value of P1. So here since process 2 to 3 and process 4 to 1 both are constant pressure processes, that's why I can write as a P2 is equal to P3 and P1 is equal to P4. Now here if I'm going to put P3 instead of P3 as a P2 and instead of P4 as a P1, then if I see the equation 2 and equation 3 दोन्ही पण बघा equation 2 आणि equation 3 राइट हँड साइड काय येतात सेम येतात P2 by P1 raised to gamma minus 1 upon gamma. इथं पण काय येते P2 by P1 raised to gamma minus 1 upon gamma. So here by equating the equation 2 and equation 3 as right hand side are same as right hand side दोन्हीच्या right hand side काय येतात त्या ठिकाणी पण बघा की काय राईट हँड साइड काय येते P2 by P1 रेस टू गॅमा मायनस 1 आणि इथं जरी P3 by P4 होतं पण P3 म्हणजेच काय P2 आणि P4 म्हणजेच काय P1 म्हणजेच काय झालं P2 by P1 झालं. So as right hand side of both the equation are same, so I can equate the left hand side. So by equating the left hand side, so left hand side is nothing but T2 divided by T1, T2 divided by T1, here T3 divided by T4. So T2 by T1 is equal to T3 by T4. Are you getting? Yes or no? Now here if I'm going to make the modification, so here if I'm going to take this T1 term towards this direction and this T3 term towards this direction, then I will get that same equation I can write as a T2 by T1. I will erase all the things. So same equation, if I'm going to take this T1 term towards this direction and T3 term towards this direction, I will get that T2 by T3 is equal to T1 by T4. T2 by T3 is equal to T1 by T4. So here, if I'm going to check now equation number 1, तर मी equation number 1 जर check केलं, so here in that equation number 1, instead of T2 by T3, instead of T2 by T3, I can put the value of T1 by T4 because T2 by T3 is nothing but T1 by T4. So here, if I'm going to put this value of T2 by T3 as a T1 by T4, so here, if you see the numerator and denominator, then T1 by T4 minus 1, T1 by T4 minus 1, T1 by T4 minus 1. So that term will get cancelled, and finally I will get the equation number 1 as a COP is equal to T4 divided by T3 minus T4. T4 divided by T3 minus T4. Are you getting up to here? सगळ्याला समजलं का इथपर्यंत? होय की नाही?
Yes, sir.
Huh?
Yes, sir.
Okay. Now,
Yes, sir.
here I'm getting that COP is equal to T4 divided by T3. Sorry, T4 divided by T3 minus T4. So here if I'm going to take T4 term as a common term from the denominator, so as I'm getting that T4 COP is equal to T4 divided by T3 minus T4. So here if I'm going to take T4 term as a common term, then I will get that 1 divided by. So here I'm getting the T4 term as a common term. So this denominator T4 and numerator T4 will get cancelled, and finally I will get the equation as a COP is equal to 1 upon T3 by T4 minus 1. 1 upon T3 by T4 minus 1. So here T3 by T4 is nothing but, at you can बघू शकता तुम्ही, T3 by T4 is nothing but, here you are knowing that T3 by T4 is nothing but P3 by P4 raised to gamma minus 1 upon gamma. तेच P3 by P4 म्हणजेच काय P2 by P1 raised to gamma minus 1 upon gamma. कारण की काय माहिती आपल्याला P2 is nothing but equal to P3, P1 is nothing but equal to P4. So here in this equation, P3 by P4 is nothing but equal to P3 by P4 raised to gamma minus 1 upon gamma, which is nothing but equal to P2 by P1 raised to gamma minus 1 upon gamma. So here, whatever P3 by P4 term is there, that is called as the expansion ratio. That is called as a expansion ratio because 3 to 4 process is a isentropic expansion process. So P3 by P4 term will be called as a expansion ratio. Expansion ratio means pressure before expansion divided by pressure after expansion. And whatever process, sorry, P2 by P1 term is there because 1 to 2 process is a compression process. So P2 is nothing but pressure after compression, P1 is nothing but pressure before compression. So that will be called as a compression ratio, RC. Compression ratio, this is called as a expansion ratio. So here if I'm going to put in generally, so here I will get that COP of Bell-Coleman cycle. So COP of Bell-Coleman cycle is given by equation 1 divided by P3 by P4 raised to gamma minus 1 upon gamma expansion ratio, P2 by P1 raised to gamma minus 1 upon gamma compression ratio. So in general, I will denote that term as a pressure ratio by term RP. So COP is equal to 1 upon RP raised to gamma minus 1 upon gamma minus 1. Whereas RP is nothing but compression or expansion ratio. Compression ratio means P2 by P1, expansion ratio means P3 by P4. So most of the time for university exam, the question will be explain Bell-Coleman cycle with the help of PV and TS diagram and show that COP of Bell-Coleman cycle is equal to 1 upon RP raised to gamma minus 1 upon gamma minus 1. Are you getting? So this is the expression, or this is the proof of COP of Bell-Coleman cycle is given by equation 1 upon RP raised to 1 upon RP raised to gamma minus 1 upon gamma minus 1. What is the time now? 11. Okay. So let me take the attendance. समजलं लेक्चर सगळ्यांना आजचं? हॅलो,
Yes, sir.
लेक्चर समजले सगळ्यांना?
Yes, sir.
Okay. So this is the derivation part. So now we'll close our lecture with, let me check whether I have taken the attendance. Wait, I'm going to take the attendance. Don't remain absent for any of the lecture. So I have taken the attendance. Thank you. Now you can end my lecture and you can join the another lecture. Whether Famne sir has given the link?
हॅलो हॅलो सर.
Here.
हा सर, मेसेज सेंड होत नाहीये ह्याचा माझा,
कशाला?
म्हणजे प्रेझेंट का टेक्स्ट बॉक्स मध्ये मेसेज म्हणजे सेंडच होत नाहीये इकडून.
टेक्स्ट बॉक्स मध्ये द्यायची गरज नाही.
गरज नाहीये का प्रेझेंट?
सर सर
बरं
सर सर लेट झालं तर 4-5 मिनिटं अलाव करत जा. काल किती वेळ
नाही,
थांबलो
नाही.
तुम्ही, अलावच केलं नाही तुम्ही. शेवटी मी बंद करून गेलो ऍप सर.
लेट झाल्यानंतर कसं होतं, जर फॅकल्टी एकच मोबाईलवरती करत असतील, आता माझ्याकडे लाईट आहे त्यामुळे मी 2 ह्याच्यावरती करतोय. जर फॅकल्टी एकाच मोबाईलवरती करत असेल आणि त्यांनी जर प्रेझेंटेशन स्टार्ट केलं तर त्यांना समजतच नाही कोण आलंय कोण गेलंय. त्यासाठी लेट यायचंच नाही. मॅक्सिमम 2 ते 3 मिनिट.
लेट झालं होतं, जास्त काय झालं नव्हतं.
नाही 10चं लेक्चर असल्यानंतर आपण नॉर्मली 10:04-10:05 पर्यंत थांबतोय, एंटर करतोय. पण तुम्ही 10:15 लय लागलं तर ते नाही आलं.
नाही सर, नेटवर्क रेंजचा प्रॉब्लेम असला ना, जॉईन होत नाही लवकर. जरी
आमचा प्रॉब्लेम
जॉईन होत नाही किंवा बाहेर पडतंय.
ऐकून घ्या.
काल प्रॉब्लेम
ज्यावेळेस आमच्याकडे फक्त एकाच मोबाईलवरती प्रेझेंटेशन देतोय, त्यावेळेस स्क्रीन शेअर केल्यानंतर आम्हाला समजत नाही कोण आलं आणि कोण गेलं. तो प्रॉब्लेम. आता 2 असतील, लॅपटॉप आणि मोबाईल असतील तर त्या ठिकाणी एंट्री करता येते.
सर मेसेज पण बघत जा मधून मधून, कारण दुसरे स्टुडंट जर सांगत असतील ऍड करा, आम्ही त्यांना सांगतो ना ऍड करत नसते तर त्यांचं ऐकून तरी मग बघत जा. असं म्हणणं आहे आमचं.
जास्तीत जास्त 5 मिनिट लेट अलाउड आहे.
हा सर, 5 मिनिटच झालते काल. 5 मिनिटानंतर पुढे थांबलो होतो, परत ऍडच केलं नाही.
भगवान मला
शेवटी मी बंद करून
चांगलं माहित
गेलो
आहे मी
सर.
किती वाजता लेक्चर चालू करतोय ते. काल मी 5-10 मिनिटं थांबलो होतो.
बरोबर आहे सर. आज तो उशिरा म्हणतोय की, मी कुठं नाही म्हणतोय का, पण लेट झालं होतं काल, अलाव करायला पाहिजे होतं सर. खूप भरपूर वेळ थांबलो होतो मी. 3-4 वेळा टाइम आउट झालं तरी ट्राय करत होतो मी.
अलाव करायचा प्रॉब्लेम काय येतोय, काल लाईट नव्हती माझ्याकडे, मी मोबाईल वरती घेत होतो. प्रेझेंटेशन स्टार्ट असल्यानंतर मला समजत नाही कोणाचं आलं आणि कोणाचं गेलं. आणि ज्यावेळेस आम्ही मोबाईलवरती प्रेझेंटेशन देत असतो त्यावेळेस नोटिफिकेशन ऑफ करत असतो, कारण की नोटिफिकेशन ऑन ठेवलं तर सगळं ते प्रेझेंट होत असतं. त्यामुळे नोटिफिकेशन ऑफ केल्यामुळे कुठल्या ग्रुपला कोणता मेसेज येतो हे सुद्धा समजत नाही. त्यामुळे तुम्हीच काळजी घ्या इथून पुढे.
बरं
चालेल, करा, क्लोज करा.
मंडळी